is Ceres in resonance with a bigger body? Did it migrate during the formation of the solar system, do you think? That's from Twitter.
So yeah, so I can comment on that. So 2 questions here. So first, Ceres is not in resonance with a bigger body, but it's been suggested that you have a bunch of small asteroids that are on the same exact orbit as Ceres. So in some form, they are in resonance with Ceres, and there are about 35 to like 45 of these objects predicted so far. And so that could be something that Dawn could see on its way during the approach phase to Ceres. Regarding the migration from the outer solar system, it's a little bit difficult to prove from a dynamical point of view. I mean, many people have worked on this topic, and I think they predict a probability of capture of about, I think, less than 10%. The migration part is not so much the problem. The problem is more about, how do you capture an object that is so massive? How do you break, if you want, the course of an object that is so massive? But it's not a zero probability, so, I mean, we'll see.
Julie, I think you also wanted to talk some about the astrobiological potential of Ceres.
Yeah. So I mentioned earlier that big thing with Ceres. I mean, we talk about it having an ocean. We talked about it having ice, and maybe, I mean, there are carbonates on the surface. So maybe, we can speculate that Ceres could be similar to other icy satellites for which a deep ocean, possibly inhabited, has been suggested. Can you please put up my slide about a comparison between Earth, Europa, and Ceres? So it's a chart that basically in the first column lists all the attributes that that makes a body habitable. And I have tried to quantify one possible, or at least qualify, what we think is going on at Ceres compared, again, what we think is going on at Earth and at Europa. And Europa is this very huge astrobiological target. So basically what I've done is looked at, does this body has a deep ocean? And it's been suggested from geophysical modeling that indeed Ceres could have preserved, at least at the equator where the surface is warmer, it could have preserved a liquid layer that would be a few kilometers thick. That this layer could have salts. I have tried to quantify the heat budget of Ceres, and the heat is very significant at Ceres. So at Europa, we know that the heat source is primarily from the core, from radiogenic heating, and also from tidal heating, from the consequence of Europa's interaction with Jupiter. So Ceres is not in resonance, as we just said, it's not in resonance with the Sun or any other body, but it's very close to the Sun, and basically the Sun is the main heat source for Ceres, as it is for Earth. I mean, it's one of the key heat sources for Earth. So the surface temperature of Ceres is so warm that its ice can deform very easily, and this drives likely the internal processes and what we call convection, the motion of material within the icy shell. And that motion of material is very important because what it can do is bring material deep in the interior of Ceres, like for example from the ocean, and bring it to the surface of Ceres. So let's say you have very elaborate organic molecule in Ceres' ocean. There is some prospect that convective motion within the ice shell could bring that material to the surface of Ceres. And then I looked at other things, like, for example, is there a prospect for hydrothermal activity, like we find on Earth, and has been suggested for Europa. And, the presence of carbonates on Ceres, as mentioned earlier, is kind of evidence for hydrothermal activity in the past of Ceres. There are other information that we can think of, but these 3 aspects, the chemistry, hydrothermal activity, the heat source, and the prospect for convection within the ice shell are the key ones that make us think that Ceres could have been habitable, at least at some point in its history.
And this also answers a question, oh gosh, I need to find it. Charles Bell asked if there's been a calculated range of surface temperatures for Ceres, and so that's right here. It says 130 to 200 Kelvin. Below the thermal skin, what was the thermal skin?
So basically, there is a layer on the outside of any asteroid or any object, basically, that the surface, there's a layer basically that changes temperature wildly depending on whether it's lit up or whether it's in shadow. So that's what we call the thermal skin. So when we say surface temperature, that's basically the stable temperature, the most stable temperature. So it's a few centimeters underneath the surface. So it's effectively it's the surface temperature. It's basically how deep a thermal wave would penetrate into the object. So it's kind of like if it's a hot day, it's a hot day out, and then the sun sets. The very surface sometimes of a material that you're standing on, you still might feel some of the warmth coming back up from down below. So it's that kind of like an insulated layer kind of thing.